A setup here. We've got a principal axis, we've got our diverging mirror looking like this, and what we're going to do is we're going to work on our three light ray rules. Diverging is a little difficult compared to converging, I think. So let's just go through this one at a time here. So we have a light ray that comes from the tip of the object, and it goes, let's say the first one is going to go parallel, because our first rules always talk about parallel light rays that are parallel to the principal axis. Okay, so when this light ray hits the mirror, being that it's a convex or diverging mirror, it's going to reflect away from the object. It's not going to converge down here, it's going to reflect away. And it's going to reflect in such a way that it's going to go away from the focus. So I'm going to line this line up right as best I can with the focus. Okay. Now, everyone understand that so far? It's diverging mirror, okay? I know this is a bit of a flat part here, so it's tough to see. But, you know, if it looked like this, you could kind of really understand that, hey, it's reflecting up and out. Okay. Now, what you do behind the mirror is you always extend the reflected ray. So that's the reflected ray is this part right here. That's the reflected ray. So we're going to extend, and again, you want to do this with a ruler. And you want to make dotted lines that are an extension of that reflected ray through the focus. Okay, so that's law number one, or rule number one for ray diagrams. Parallel focus, right? Parallel focus, parallel focus. That's rule number one. Rule number two is focus parallel. So where's the focus? Well, here's the focus. So you've got to draw a line that would go through the focus. Now, I'm not going to draw the solid line behind the mirror. I'm just going to draw the solid line up to the mirror. Okay? That's the line that would go through the focus. Now, what you don't want to do, guys, what you don't want to do is draw a dotted line between here and the focus now. Okay? We do not want to do that, and that's what many students do, and it causes real problems. Remember, what you have to do is you have to extend behind the mirror, you have to extend the reflected ray only. So this is going to, I'm going to do this as best I can. This is going to be parallel, reflected, parallel. Okay, so focus parallel is rule number two. And behind the mirror, because notice these light rays are not going to converge on this front side of the mirror, right? They're going away from each other. So there's going to be no image there. Where is the image going to be? On the back side of the mirror. So we extend now the reflected ray as best we can here. Use your ruler and such. But we can see that now these light rays are going to converge here behind the mirror. One final ray that you could draw would be the one that would go through the center of curvature back here. And so I'm going to draw this line here. All right. And then I'm going to extend that reflected ray because it would bounce off this mirror and it would go back along the same path, right? So I'm going to extend that one behind the mirror so that it goes through the center of curvature. And look at what we have. Now we have a clear indication of where our image is. Because these light rays came from the top of the arrow, this is also going to be the top of the arrow where the light rays converge. Straight down to the principal focus, or the principal axis on a 90-degree angle, and that's where your image is. All right? And of course, the characteristics of the image, we can write those characteristics of the image. Okay, so is it upright or inverted compared to the object? It is upright. Okay, is it larger or smaller than the object? Smaller. Okay, and is it, what's the next one? Wow, we could do real or virtual, right? Real or virtual, is it real or virtual? It's behind the mirror, so it's virtual. And then I guess the last one, position. Where is it compared to? It's between, you could say between V and F, or between the mirror and F, or inside F, or whatever you want to say. So between mirror and F. Okay? And you just said it's virtual so they know it's behind the mirror. Okay? Now, if I asked you to give specific dimensions of the characteristic, be specific, then what you would do for upright, smaller, you would give a distance, a height. So height of image equals, and you would actually measure that with your ruler. Position, you would give the distance of the image here. So how far exactly from the mirror is this length, okay? So upright, there's no number attached to that. Virtual, no number attached to that. But the size, you should put the height. If it's upright, the height is positive, okay? If it's inverted, the height would be negative, yes, okay? So you can have a negative height here. That means something, all right? And yeah, let's see, for distance of the image, I think the distance in front of the mirror, if it's real, should be positive. The distance, if it's virtual, I believe should be behind the mirror, but don't quote me on that one. We'll have to check on that one. Let me check. Yeah, so the distance for virtual objects would be negative. The distance for real objects is positive. Okay? All right, any questions about this example right here?